Okay, now let's talk about inverse Laplace transform. As I told you, the Laplace transform method is kind of like you move your problem to the other world, which is Laplace transform. Then after like take care in that world, and you have to take back your solution from the other world to your world, right? It is inverse Laplace transform, okay? So now we're gonna practice that, okay? There we go. So basically, whenever we have this kind of function in that world, then we should like split with two separate fraction, okay? Which is 1 over s squared minus e to the minus 2s over s squared, okay? So here we go. Then your function f of t, which is inverse Laplace transform of fs, is equal to inverse Laplace transform 1 over s squared. And we are familiar with this form, right? Because like it is in the table, okay? And minus inverse Laplace transform of e to the minus 2s over s squared. And this is also like, really familiar with you guys, okay? So, so what you're gonna do is like, it might better to write this one as e to the minus 2s times 1 over s squared, okay? Because like, you have to remember this, okay? This one is like in concern with a unit step function. That's why I would love to split like this way, because it's like we have used the number 13, okay? So here we go. Then look at this one. Check your table. Then it is concerned with number 3, right? Here we go. So we know about that one. It is just simply t, right? That's it. Okay, and this guy, e to the minus 2s came from unit step function, which is u2, right? And then like, to match with the number 13, okay? Look at number 13, I'm talking about this, okay? Oh, your Laplace transform world function form must be e to the minus cs and f of s, right? Keep that, it must be f of s and it will be f of t minus c, okay? Here we go. So what I want to do is, okay, like to help you to understand what you're doing, let me write it here. Number 13, okay? Because like you need a lot of practice for here, okay? It will be E C T f of t. Okay, let me write g of t instead, okay? Is equal to inverse Laplace transform of no, number 13, right? That's what I'm saying, okay? U C T f of t minus c is equal to inverse Laplace transform, hi Alison, of e to the minus cs and f of s, okay? Let's try to match, okay? So like when you compare like this table thing and this one, definitely this is, oh, what about it? Let me write g instead, okay? This is g of s part. Is okay? It's like by number 13, like this e to the minus 2s times 1 over s squared form, like, I mean, like inverse Laplace transform of this guy is like definitely u2 t and g of t minus 2, okay? Where your gt is inverse Laplace transform of your g of s. Does it make sense? Okay. And my g of s is given here, 1 over s squared, right? Which is equal to inverse Laplace transform of 1 over s squared, which is equal to t. I'm talking about number 3 as well, okay? Does it make sense? Then, okay, we're going to plug it back this one into here, but keep that in mind. Not gt, but it must be gt minus 2, okay? So it is equal to t plus u to t times g of t minus 2, which is t minus 2. That's it, okay? I plug in t minus 2 into my g of t, okay? That is the way to find inverse Laplace transform.